Okay, so this is the continue of the previous EKS code. So we have pushed our front end into our ECR. Now it's time to push our backend into that ECR. So again, your backend will contain number of files in which you have to create another file name as a Docker file for your backend. Let's see what is inside this one. Okay, so again, it contain a node. So you required a node for your application. Then you have this working directory where all your data will be put. Okay, when your image or container will get created. Then you are copying all your package.json file into this app one. Okay, the previous working directory that you created. And now to run this one, you are running this command npm install. So you need npm in your system as a package build manager. Then you are copying all the source code from your current directory to your image directory, that is the work directory. And then to run your main file is node index.js file. So you have to run this file. So node index.js file. If you ever run any backend file or any node file, you have to write node and then index.js. In example of if you want to run Python file, you have to write Python and then the file name. So here command in that scenario would be Python and then file name, suppose app.py. So in that case. So this is our Docker file. Let's exit. We created and now it's time to push our Docker file. First we establish a connection with our ECR. It says login succeeded. We got the connection. We'll copy the command to create image. So docker build -t web backend and then dot. So this will create the image of your backend. Got it. It got created. Then we are giving it a tag for recognizing our repository. Tag is given. And then we are pushing it to our backend registry. It takes a couple of time. Till then, let's see whatever we have done so far. We set up our EC2 machine, right? We created this IAM user as well. Then we installed AWS CLI, okay, and we configure it as well in our previous class. We installed Docker for creating the images and all, and we give the Docker user to the username added to the Docker group. Now, our next task is then we pushed all our Docker images into that ECR. Now, what is our next task? We have certain, we want to create pods. For that, we need to have kubectl in our system, right? So it's a link that is downloading the kubectl, but I don't want this one in there. It's a command which will actually download on your system. Okay. So the backend is done. Close it. Refresh it. And we got our backend as well. If you see the repository, we got our web frontend and web backend. Both are on our ECR. So anytime we can bring it and push it over here. Okay. If you remember our previous Kubernetes class, for creating any pods, we need to create a manifest file. Okay. Those are the YAML files. One was known as development.yaml file. Other was known as service.yaml file. Remember? You go to Kubernetes documentation. But before that, where is our DevOps. Okay. Now, our next, what we did so far, we created that front end into that Docker images and put in the ECR. Again, we created this backend one, created the image out of it and put in the ECR. Now, the next we are going to do this MongoDB. We will create the image of this one, amplify with the Docker, and then we directly create a pod of this one. Okay. So this is going to be our next task. And in the similar fashion, we will do with the front end and the back end, and we will create a pod of this too. So this is our code. cd dot dot. So far we looked into this application code where we had this backend and we had this front end. Okay, where we created this Docker file, and in the backend as well, we created this Docker file for the backend as well. Any idea what is the meaning of this docker.ignore?
Ignoring the file which is not with that extension. Whatever
Not
extension.
to be created as an image. Yeah, so whatever the file mentioned in this one will not be created in the image. Great. So now what we are going to do, we have this manifest.yaml file. Okay. So for database, you have to have a different one. For backend, you have to have different one. For frontend, you have to have different one. For now, let's just focus on backend part. Sorry, database. So what are we going to do? Two files will always be compulsory for either backend, frontend, or database. That is deployment.yaml file, which looks like this. Okay, we'll try to look into this one, and service.yaml file. Okay, this is compulsory. We created in the previous class as well of Kubernetes class. Further, three more new files we can see. One is the secret, which basically contain the password and the username in encrypted format. So if you want to encrypt anything into this, and if you want to get the encrypted of any password, you can just simply use echo, write your password, suppose Akash123, and then write base 64. So it will generate an encrypted number or data of your this one of your whatever the password you give. So the same thing I applied over here. Okay. And if you want to see what is inside this one, just copy this one. So instead of your password, paste the decoded as encrypted one, and in the end, just write decode. Okay. So it will encode it, encrypt it back, decrypt it back. Sorry. Understood how to create the password, how to create the encryption form of that password. So the same thing done over here. API version will remain same kind. You have to mention what is this file format. So it's a secret one. Metadata namespace. Okay, this namespace is important. So namespace basically says you will create a separate workspace for your all Kubernetes cluster, all Kubernetes pods. Okay, so where are all these going to be? So you have to create a separate space for that one. So for that, this namespace come into the picture. The name is 3-tier. Okay, so 3-tier namespace means it will create a separate workspace for your all your Kubernetes files. Okay, let's go back to the code. So we'll come here. front-end backend, let's come out from here as well. And to interact with Kubernetes, you need to have Kubernetes in your system. Okay, so let's just download it quickly. CD. So to install kubectl, just copy this one. Not the key. Copy this one. So what this will do? This will create a folder for your kubectl where all your kubectl data will be stored. And then after, okay, any idea what is the meaning of chmod plus x kubectl? So if I do ls,
Yeah.
yeah, please continue.
We are giving the permission for to kubectl to execute a
Correct.
file
What kind of a permission we are giving?
or execution.
Hi Vishnu,
Hi Akash.
quite late today.
Sorry, my phone was not with me, so I didn't notice. Sorry for that.
That's okay. We are recording so you can see it. Okay.
Yeah.
So we created one folder over here named as kubectl. If you want to check what are the permission it is having, do ls-al and press enter. So it will show you this kubectl is having only read write, no execution permission. So to give execution, we just do chmod plus x means you are adding execution to user, owner, and others as well to this kubectl file. And I'll press enter. We have given this one. And then what we are doing, we are copying the kubectl data, okay, into this environment variable named as bin, moving it. Paste it over here. We moved it. Okay. And now if we do kubectl client version. So if it shows the client version is this, it means you got the kubectl in your system. So this one, install the kubectl and created a folder out of it. We have given permission to it. With this one, we moved whatever the necessary kubectl data into this bin folder, and we can check the client version as well. So if it shows the version, it means it got correctly installed in your system. Okay, so we install kubectl. Kubectl is used for giving command to Kubernetes type of things. But if you want to interact with AWS EKS, you need to install EKS SCTL as well. Okay. So let's do it. So remember, to interact with kubectl, you just install, to interact with Kubernetes, just install kubectl. But if you want to interact with the EKS, you have to install EKS CTL. Any idea what is the meaning of silent over here? You can keep it, you can remove it. It's totally on you. So silent means in the backend, all these processes that you see when one is doing every processes will happen in the backend. You need not to worry. So everything is happening on the backend. I'm not seeing anything. Okay. Then again, moving all the necessary file of EKS CTL into this bin folder, which is the environment variable. Done. And then after, we just check the version. So it showed the version, it means it is also installed correctly. Great, we installed both. Now we need to create EKS cluster. Okay. So you need to have EKS cluster in your system to run or to create the pods, because these pods will directly go into your EKS cluster. So am I audible? Hello. Seems like some network issue. God, no, not yet. Guys, am I audible?
Yes, Akash, you're audible.
Okay. So if I do EKS, Elastic Kubernetes cluster. So there are two ways. You can create it manually, create cluster. Okay. See, there is one created cluster. Okay. I don't know from where it comes, but it seems like it was created September 12th. Okay. For now, let's just delete it. So it's getting deleted. Okay. You can create cluster manually from here, but for now we will create cluster from our code. So let's understand that one. Okay, so it starts with EKS CTL, which we have just downloaded it. Create cluster, which will create a cluster. What will be the name of your cluster? So the here name is create a 3-tier cluster. Okay, you can keep it whatever the name you want. Let it be here. Then you have to choose a region. Okay, so this region should be where you are working. So let me just check where I'm working. What is my region? So if I click Ohio, it is US East 2. So you have to change here. US East. US East 2. Okay. Now node type for Kubernetes cluster, you need to have T2 medium EC2 instance. So it will create an EC2 instance of T2 medium. Then minimum node 2 and maximum node will be 2 for now. Okay, means 2 EC2 instance of T2 medium will be created. So I'm just going to copy this one. Now this will take approximately 10 to 15 minutes. Okay. So this is the issue that I was thinking. I could have done that one earlier, but the problem is you won't be understanding. So that's why. Anyway, no worries. So if I go to cloud permission, see EKS CTL 3-tier cluster, which is the name of our cluster, got created over here. Okay. Now what will this do? If you go to resources, you can see it will create a lot of resources for you. It will create a control plane. What is the use of control plane? Any idea? You should have the idea. What is this control plane? Supriya, Shreya, Vishnu. Guys, hello.
Master node.
Yeah, master node. And this is our shared nodes, which is the worker nodes. Okay, 2 EC2 group will be created for this one. Then control panel security group is getting created, ingress is getting created, internet gateway is creating, NAT gateway is creating. So all this public route table, all these things you need to require. So either you can do manually all these things, or just by one command you can create all these things. Okay. So the most easiest one is by creating through the command. So we install this one, we looked into this one. Okay. We need to configure this with our cluster. Okay, so it will take a little bit time. Till then, it is taking time. Let's go and see the YAML file. Okay. So in database, first we'll do with the database. We have this deployment.yaml file. Let's take a look into this one. API version app.v1 always remains same. Kind, you have to say what kind of a file it is. It is a deployment. Namespace, you have to mention this metadata, where will it go? Okay, so we are creating a worker space for this one. And then name, so it is for the MongoDB we are doing. Specs, if you remember, we created the replica. So here we are creating only one replica. Okay. And match label, I told you it is very important. This one has to match all the labels of your template. Okay. So this one, whatever the worker node we created, so this one will be attached with your control node only using this match label and this label data. Okay. And inside this container, we have this name as mon. Okay. Image ID we have to give. So this one will be get fetched through the Docker Hub. Okay. And the command, these are the command that will run under inside this one to bind. It is required. MongoDB include all this command if you want to get the image out of it. And then port number. So the default port number is 27017 of MongoDB. Even if you go to the Docker Hub, just search Mongo. So this Mongo, if you go down, so you can see port number, here it is. So by default, the port number is 27017. Okay, and these are the extra thing that you need to give while taking the image of Mongo. Okay. Great. Let's go further. Environment variable. Okay, environment name you are giving, and these secrets. This is very important. And this secret is actually attached with this secret.yaml file. So the key and the password you are passing will come here for the connection purpose. Okay. So secret reference again we have given for one for the username, one for the password. And then volume mounting. Okay. So what we are giving some space to this MongoDB into our database, into our EKS cluster. So for that, we have to provide this volume mounting. Okay. And then this one, persistent volume claim. So whenever you create volumes, you have to claim that volume for your MongoDB. So for this, we created two other file, persistent volume and persistent volume claim. So these two files is compulsory if you are going to access the database, okay, from your ECS to your EKS. So you require these two file as a compulsory one, okay, because these two are handling your persistent volume. basically the space and the access to from that space. Understood this deployment.yaml file?
Yes, Akash.
Okay, if you want to get the pretty idea, you can just simply go to here, go to the documentation, just search deployment and press enter. So they will provide you a initial template for creating this one, okay, which is almost similar to the one that we created. Okay, and then you have to see this one, service one. So service is basically handling the port. You have to provide the port for the host port and the target port. Okay, so both are right now it is remaining the same. Port volume, port name is given MongoDB SVC as a service name. Rest of the things, namespace will remain same in all the deployment file, all the YAML file, because these are going to be going to take the space in a single workspace. So the namespace will remain same for the all files. Specs selector app Mongo. Okay, this will also remain the same. And that's it. Nothing much in this one. Then secrets, we looked into the secret, how to create the password and the username. Okay, even if you go to here and type secret, you will get the initial one. So it seems quite long. Let's see the smaller one. Here also you can take this one as well. But I'm looking for where it is mentioned the password and the username. There's a JSON in the JSON format. They mention the password and the username, but here it is. This is the main one. So app version v1 kind secret metadata name. The name is basically whatever the name you want to give. In the name we have given namespace as well. Type, what kind of type of it is. Okay, it is going to use the basic authentication with and string data, username and the password. So these two are helpful for connecting you with your database. Let's see. It is still under progress. Understood? All this deployment PV persistent volume. Okay, it will create the volume and this will allow you to give the access read and write access to that volume. That is persistent volume claim. Secrets, we understood it is necessary to connect with your database. Service will give you the port on which you will run your application. Okay, and this deployment.yaml file is the basic file that required to create the pod of your database. Okay, rest these files are creating the environment for this deployment file. Okay, any confusion or any question? So if you see CNI is getting created, you can look. Any idea what is this cloud formation? What is the use of this service? So
It is
basically,
infrastructure as code, Akash.
infrastructure as code. That's very good answer. But how will you a little bit elaborate? Could you please elaborate a little bit? If someone has to understand infrastructure as code.
So for a layman person, if I have to say, if we want to
Mhm.
set up some infrastructure, like some cloud services, we can just write a script and we can get all the services deployed.
Absolutely right. Okay. For example, I create VPC, I create security groups and a lot of things, a lot of this one. And now I want to create it again. So are we going to do the same manual task again? So the better option for the organization perspective is that they write a code for that one, either in JSON or in YAML. Okay, generally JSON it is. So in that format, you can just copy that code and you can paste it as many services you want. You want to duplicate that services in the future or anything, you can easily do that one. Even this one is getting created through that cloud permission the same. As a code, we are creating all these services. Great, good. So how far? Okay, so waiting for the cloud permission stack. It's getting created. Okay, till it is getting created, let's see other YAML file as well. So we understood this database YAML file. Okay, so we will create a pod out of this one, first database. Then we will create a pod of this front end, which is pretty much easy. You just require two file deployment and then service. Secret, PV and PVC, we do not require here because front end, we are not going to store anything. We are not going to access anything. We will just show it. Okay, so it's also the same. API version and the kind will remain same. Metadata, what is the name, front end. Namespace will remain same throughout your code. Okay, label you need to provide. Then spec replica, create one replica. Rolling update, any idea what is the meaning of rolling update? So whenever the new changes comes into play in your front end, this rolling update will take that new changes and discard the previous one. Then maximum, this one, rolling update. So the thing is, if any changes goes more than 25% or any percentage, here it is taken a 1%, 5%. So it will replicate, keep this the current one and discard the previous one. Then comes your match level. It has to remain the same. Okay, label, all these things remain same. Image pulling, we are pulling the image from our ECR. Okay, ESCR registry secret. Okay, what image we are pulling? The front end one we are pulling. Okay, so you need to provide here the image, correct one, correct image. So how will you get this one? Just need to go here because it has to identify where is that front end one. So you go here and you do public listing. So it will give you a public listing code. You copy this one, okay, and put it in your image one. So with this one, it will identify that the image is actually front-end image is actually stored in the ECR at this particular location. Okay. Then environment. To access your front end, you required a URL, right? So either you need to have a domain for this one. You required any domain, okay, to access your front end part. So for now, we have just given a vague. Okay, this is not the correct, accurate one. Container port is 3000. So front end will be hosted in the 3000 port number. Okay. Your database is getting stored on port number 2027017. And the same if you look for the backend. Okay, everything will remain the same. Nothing is rolling update and all. You just have to change. And backend is going to connect with your database, right? So you need to provide this database credential. How will you get this? Everything will remain same. You just have to change this name, which you have mentioned in your deployment YAML database, Mongo SVC, Mongo SEC, this name, SEC. So this name should match. Oh, sorry, it is SVC. So service, here it is. So this name, this service name has to match with the URL that, not the URL, Mongo connecting data. Backend will get connected with this one. And then after this one will be taken from the secrets. No need to worry. Okay. Same, you will create a service file where you will. So it is getting hosted on the port number 3500. So front end is on 3000, back end is on 3500, and your database is on 27017. So it is got created. Okay. If you go here, permission. So we can see we got one cluster of with the name of 3-tier cluster. Okay. It is in the active state and everything has been done. So our cluster is got created. Now the only task that we have to create the pod. Okay. So any confusion so far, whatever we have discussed, all the YAML file, how to create the cluster? Okay. Now you can have thousands of cluster at one time. Okay. In the organization. So to redirect or to direct your EKS into this particular cluster, you just copy this code, AWS EKS update config. Okay, region, whatever the region you are available. For now, I'm having just one cluster, so need not to worry. Yeah, I can put this command or I cannot. Okay, it's completely fine. But let's keep it. That's a good practice. We have the region US East. Okay, rest of the things. Name of your cluster is same. Update config. So now whatever the command you will do, everything will be get access to that particular cluster. Okay, added the new context. Okay, so everything now will be access to this one, 3-tier. So whatever the command I'll write over here, all those command will directly go and check or do the all operation on this cluster rather than any other cluster. So if I do kubectl get pods, right now no resources, because what is the namespace we have given? 3-tier, if I remember correctly. 3-tier. Okay. So everything is available on 3-tier. Right now, you cannot access, this is the default namespace. So you don't have anything on your default. So do -n and then 3-tier name. 3-tier. So no resources, no pod we have created so far in this one. Okay. So let's go and create some pod. So the pod will be created based on whatever the YAML file you have. Let's go to EKS. ls, then Kubernetes manifest file cd ls. Okay, then I have to go inside the let's go with the database first. Cd database. Okay, if I do ls, we have this. So all this you have to create a pod of this one. So how do you create pod? kubectl, anyone remember? Apply -f deployment.yaml. Okay. So what is the error? The error is server. You need to create a, okay. We have not created any this one workspace here. Okay. So we have this workspace on our system, but we do not have this workspace on our Kubernetes cluster. So we need to create. So kubectl create workspace. What was the name? 3-tier. Just check where it is. kubectl create namespace. Okay, create namespace, not the workspace. Yeah, we got our namespace created. if I apply kubectl, get pods. So no resources, pods -n, and then do 3 tire. So no resources. Let's create our pod. kubectl apply -f deployment.yaml. So it got created. Okay. Now if I do kubectl get pods, so it should show the MongoDB pod has been created. Okay, but it is not started yet. Right now it is just created, but it is not in the running state. Let's create the other pods. What are the other pods? Service.yaml. Then we have secrets.yaml. This is also not created. Then we have PV persistent volume. YAML. And PVC persistent volume clean. If I do kubectl get pods -n. So this one, okay, it should be in the running state. We created all the pods. The pods got created. Yeah. So now it is in the running state. Okay, so it takes a little bit time to get ready. So this one is totally ready. Your MongoDB pod is completely ready. Now you have to create 2 more pods for the front end and for the back end. And that will remain the same. If I do cd double dot, if I do what? Same command ls, we need to go inside this backend. Let's create for the backend one. cd backend, then deployment and service. Only 2 YAML file is here. Deployment.yaml created, and then service.yaml created. Now if I do kubectl get pods, we should have 3 pods. Sorry, 2 pods. One for the backend, one for the front end. So yeah, here it is. So we have 1 pod for this backend, sorry, for the MongoDB, that is the database. Other 2 pods are for your backend one. Okay. Why 2 got created? Did we repeat something? Might have somewhere mentioned 2. Okay, so the replica set is 2, so that's why it created the 2. In the front end, how many we have mentioned? In front end, we have mentioned only 1, so it will create 1. Okay, so remember this one. If 2 pod is getting created, it means your replica set is 2. If 1 pod is getting created, it means your replica set is 1. So let's quickly create. I'll come out from this too. See the front end. And do the same command because it also contains the 2 file with the same name. We need not to do too much. kubectl and then service. That's it. If I do kubectl get pods. So we got all the pods. Front end, we got it. Back end, we got it. And 2 pods we created for the backend and 1 pod we created for the database. this was the whole motto. Okay. So up till here, they will ask you. Now the other task is to make it live. That's again a new section. So that will take another class, but I don't want to go into that depth. This was by far all the Kubernetes task is done till here. Now further task is out of Kubernetes task. So I'm not going into that one, okay, because we have the limited time. So far, any confusion? We have deployed all our Kubernetes into our Kubernetes cluster. Okay, this one. So a lot of things is here. You can see the compute, networking, resources, all the networks, subnet, cluster, groups, API access. Any confusion, guys, anywhere creating these pods? Supriya, Shriya, Vishnu.
No, Akash.
So you need to take care how to create the manifest file. Okay, Kubernetes manifest file. If it is of database, it is a 3-tier application, okay, where you required front end, back end, and the database. So that is the most complicated. You companies go beyond this one too, but average company, you for any organization, you need to have idea of these 3 services. So front end, back end, and the database. How will you connect and access the things? So we have you need to create the pods. How will you? What are the things you? How you will attach your EKS kubectl Kubernetes to your Kubernetes cluster? How will you create the cluster? Okay, how will you deploy your pods into that cluster? And in the ECR, how will you connect your this deployment part to your ECR? Okay, so one thing we did mistake. Okay, we should have changed this one. Okay, this image name to this one, and I could not do in the GitHub repository because my source code is only available, is right now available here. So I'll just tell you, if you want to replicate, you can. CD double dot and then CD application, CD, it's the front end. And then we need to look into this one. What was the file name? Sorry. This deployment, you go to Vim, deployment, insert, come down, and this image name, you delete it from here. And this one, copy the front end one and paste it over here. Escape colon WQ, save it and exit it. Now you create the pod. Right now, create the pod of deployment. Then it will target your ECR. Okay, previously it was targeting some other one, which was not your ECR. But right now it will target your particular image, which is available in the ECR. So do the same with the backend as well. Okay, if I go in the backend, here also image. So this one, you have to edit only this part. Okay, rest will remain the same. Understood, guys? Any question anywhere? I'll just stop the recording.